Welcome to the lecture series in computer science. We are seeing a series of lectures in the subject Agile methodologies. We will be seeing topics on the theories for Agile management. We will see what are the theories that are available and how this Agile management came into existence and what was the theory behind it. So, we will be seeing all those theories. So, as contents of today's session is concerned, we will be seeing theory of constraints, which is shortly called as TOC, just in time inventory, which is shortly called as JIT, and then total quality management, which is again shortly called as TQM, lean production, shortly called as LP, Six Sigma, and we will as well consolidate those theories and we will see what is the focus area about. So, that is what the management theory and focus area will speak about, and then we will as well see what are the three phases that led to the scientific development, and then we will see the principles of uncertainty and agile management, and we will see the scientific proof for the existence of coming of the agile management. So, to start with, we will see this TOC, theory of constraint. Theory of constraint was introduced in the year 1984 in Eli Godrod's business novel. The name of the business novel is said to be The Goal. Theory of constraints applied to manufacturing seeks to identify bottlenecks in the production line. In those days, during 1980s, people were mainly concentrating on the production part, on manufacturing sectors. In those days, they did not concentrate much on this software development. So, as a first theory, they were literally worried about the production, manufacturing and the outcome. So, the underlying assumption is that for this theory is that a production facility is only as fast as the slowest process in the chain. Theory of constraints improves manufacturing profitability by first identifying the constraint, then maximizing the exploitation of the constraint. The rate of throughput on the constraint is the capacity of that process, stage or machine. It is used to regulate the throughput of the whole assembly line or the system. New material is only introduced into the system at the rate that it can be consumed by the bottleneck. In theory of constraint, this technique is known as drum buffer rope. My dear students, the name of this technique, drum buffer rope, is highly important as far as the examination purpose is concerned. So, kindly make a note of it. New material is only introduced into the system at the rate that it can be consumed by the bottleneck. This technique is known as drum buffer rope. Applying this theory of constraints principle to a manufacturing plant, it has the effect of reducing the inventory of material throughout the system. So, this is about the first theory called the theory of constraint. Now, let us see the second theory called as JIT inventory, which is nothing but just in time inventory. This just in time inventory in the early 1980s, this theory from Japan was catching on in the Western manufacturing. What does it mean? The product manufacturing that is being taken place in the Western countries, in the Western world, in the Western countries. So, based on that, this theory came into existence from the country Japan in the early 1980s. Why did Japan look into the Western world? It is because the products that are manufactured in Japan, it was so cheap and the quality of the product was better comparatively. So, that is the reason the country Japan, it looked into the Western world for manufacturing, and one of the most successful Japanese companies in those times, even till date, it was Toyota. It used the Toyota production system. This Toyota production system is also called as the Kanban approach, which is devised by scientists called as Tahuchi Ohino. This system sought to minimize the inventory in the factory and ensure the required inventory was delivered to the point where it would be consumed just before it was needed. So, here usually Japanese, what they do? They used to develop, they used to produce the product, end product based on the consumption, they don't do overproduction. They do overproduction when the employees go in for a strike. In our countries, when an employee goes for a strike, they stop all sort of production. Whereas in a country like Japan, they do overproduction and they will see to that the products are not being sold. So that is the difference between our country and Japan as far as the employee labor management with respect to manufacturing sector is concerned. Then Ohino had based this technique on methods used by American grocery store chains, supermarket chains, which he had observed stacking shelves on an as needed basis, just as consumers were ready to buy the products. Ohino's technique was also known as just in time manufacturing, because based on the need the product was manufactured, based on the need of the consumer or the customer the product was given. Who is the consumer, who is the customer? A consumer is a person, is an end user is a consumer is a person who consumes the product, a producer is a person who produces the product, a customer is a person who purchases the product. So customer purchases whereas consumer consumes it. So that is the reason consumer is as well called as an end user in the recent days, and we call consumers as an end user in as far as the software development process is concerned. Next is as far as this JIT, just in time inventory is concerned, it reduces the inventory, it's reduced wherein the level of investment will also get reduced. When you are going to produce little, then the investment that is being made will also get reduced. The ROI, what is ROI, my dear students? Return on investment is said to be ROI. The ROI for a plant practicing just in time or inventory control from theory of constraints, which was the last theory that we saw in the previous slide. Theory of constraints, drum buffer rope, it will increase. The return on investment is being calculated with a formula called as return on investment equal to throughput minus operating expenses, whatever expense that you make for producing the product, divided by investment in the inventory. Here as far as the investment count is concerned, you are supposed to take the least count. So that is the reason I have given it as less. So again I repeat the formula, it is throughput minus operating expenses divided by the investment in inventory. When you reduce the expense, thereby it increases the profitability. In industries where margins are tightly scheduled, these small variations can mean the difference between whether the industry is in profit or whether the industry products has encountered a loss. So the net profit is being calculated again with a formula called as throughput minus operating expenses. So when you calculate the return on investment also, the formula is said to be net profit divided by investment in inventory, or that was expanded as throughput minus operating expenses divided by investment in inventory, whereas net profit denotes the throughput minus operating expenses. Then the next theory is called as the total quality management. In the early 1980s, total quality management was sought to bring repeatability, control and predictability to manufacturing through traceability. The total quality management espoused the notion that manufacturing could be more productive, more profitable, more efficient if quality were improved. Quality could be improved through improved traceability, which would provide audit trail information for verification and validation of quality. Total quality management gave rise to standard called as ISO 9000 nowadays, which many of the companies follow. ISO 9000, TIC IT and other quality related initiatives. Total quality management used a mental model in which the upstream process was the supplier and the downstream process was the customer. So there are only two people, one is the supplier, other is the customer. As quality improved, so did the throughput and consequently the profitability. Profitability gained from a product by selling a product. Increased throughput due to sales leads directly to higher profit and better return on investments. So, this is about the TQM. The next theory is on LP. LP denotes lean production. In the late 1980s, the industries that were put up in the Western world, they recognized that just in time and quality assurance, JIT and QA, quality assurance, had related parts to play in the overall improvement of the manufacturing industry. The term lean was first coined by Womack and colleagues in their book The Machine That Changed the World, which documented the superior ability of the Japanese automobile manufacturing processes. In Japan, in the earlier slides as well, I said in Japan the Toyota company was said to be one of the famous company. So, any examples they related with that famous company called Toyota company. So, in Japan the Toyota production system, or they have a production system, it is also called as the Kanban system. Nowadays, even in your Agile software development life cycle model, you have one other model called as Kanban, wherein which speaks with respect to the cycle time. So, this Toyota production system is also called as a Kanban system. It claims that the way that they do, they have named it as the Toyota way, because Toyota has recognized that the management method can be applied to more than just production. The management is applied not only for production, but for more than that. Then this speaks about this lean production. Then next is Six Sigma. Six Sigma is a quality related term that specifically refers to a defect level of less than 4 per million, which means the defect level is very meager, which is in the ratio of 0.00000001%. So, that is the reason the defect level is less than 4 per million. This level is considered in many industries to represent perfection. Six Sigma as a process focuses on majorly on two areas. One is quality assurance, second one is reduction of variance. My dear students, as far as Six Sigma is concerned, what is the process focus area is a pretty important question, wherein it focuses on two areas. One is quality assurance, second one is reduction of variance. It takes the position that it is better to have defects with a repeatable pattern, so that when you are going to have a repeatable pattern, it has a low variance, than defects with a random pattern. So, when you are going to have a repeatable pattern, it will always be better. The assumption is that defects that repeat probably have a common cause. If the common cause can be found, the defects can be removed with a single change or investment. The improved quality is achieved through reduction of variance. So, this is about the Six Sigma. Now, let us compare whatever theories we have seen so far. We saw 5 different theories. We will compare it with the focus areas. As far as the JIT, just in time, is concerned, it spoke about inventory, one and only about inventory. As far as the total quality management and quality assurance is concerned, as the name implies quality, it spoke about quality and conformance to the quality. Next is, as far as the theory of constraint is concerned, it spoke about the bottlenecks available and how to resolve those bottlenecks. Then as far as the lean production LP is concerned, its focus area was on inventory, quality and conformance to quality. So, which means lean production is a combination of the theories just in time and the quality assurance. As far as Six Sigma theory is concerned, it focused on quality and variance. So, this is the focus area as far as the theories are concerned. Then as far as the scientific development, my dear students, you studied those theories with respect to the manufacturing era, manufacturing field, with respect to the production environment. So now how did the software development boom in? How did we get this agile development? How this agile development came into existence? So we will see that. So as far as the scientific development is concerned, it is broadly classified into three phases. The first phase is called as classification, second phase is called as correlation, third phase is called as effect, cause, effect. So let us see what this classification does. As far as classification is concerned, classification is a phase in which nomenclature is debated and then agreed upon. People discuss what exactly is involved in the field they are pursuing or studying. They then agree on the names for founding elements or principles. Agile methods such as extreme programming, which is shortly called as XP, Scrum framework, and feature driven development, which is again shortly called as FDD, are considered as a combined science to be in the classification stage. Why do they call it as a combined science? Because when we learn about the Scrum framework, it is a framework, it is customizable, it is tailor made. Scrum framework deals with the project management approach, whereas extreme programming is a technical model, so it deals with the technicality. So when combined together, when the extreme programming and the Scrum framework combined together, you classify it and you combine it for better results. So hence the reason we call it as a combined science, so that when we combine it and when we go in for production, we get a better result. Then we will see about correlation. What is correlation? Correlation is Goldratt's term for the phase in which corroborating evidence is available to show that a method works in practice. Correlation is a phase of pattern recognition, the science of astronomy, which is nowadays it is called as astrology. By seeing the astronomy speaks about the space. Based on the astronomy, the astrologers, they give their astrology. So based on this astronomy, this astrology has came into existence. Spent thousands of years in the correlation stage, it was possible for astrologers to predict astrological events such as the turning of the year, rise of the planets in the sky, and so forth, by pattern matching against observations of recurring patterns or repetitive patterns. So this is called correlation. They correlate things with whatever has happened in the earlier years and they write it. That is what the work or the job or the duty of the astrologers. Then the third phase of scientific development deals with effect, cause, effect. Astronomy became a science after Isaac Newton proved why apples fall down. Rather than it falls down straight in the ground, it does not fall sideways. This effect was explained through its cause as gravity. The effect was the apple falling in the ground. The cause was it fell in the ground because of the gravity. Then the theory was then used to predict another effect as the Earth's orbit of the sun. When it is possible to postulate a theory or to measure the effect and validate the theory, science was being practiced or science is being practiced, because science you practice it day in and day out. It is all science. This permit managers. So now let us relate this with our recent software development scenario. This permits managers to predict the effect of a decision on a new situation based on what is already known. So these are the three phases of scientific development. Then let us see the principles of uncertainty and the agile management. The principle of uncertainty has been known in physics and it is postulated by the nuclear physicist Heisenberg. The science of physics learn to live with uncertainty. The theory of constraints teaches the business systems. Methodologists on how to live with uncertainty in other fields such as production, project management and enterprise resource planning, which is shortly called as ERP. Financial predictions for the performance of a software development business are possible, but it must always be couched or added with a degree of tolerance. Agile management is all about being able to cope up with the uncertainty. What does it mean? In agile management, when do people go in for this agile management? When the requirements are not so clear, they do not know about the requirements. When there is a rapid change in the requirements, the customer at the first run, during the first sprint, he will be giving one requirement. During the second sprint, he may change his requirements. So, when there is a rapid change in the requirement, when the requirements are uncertain, people move in for this agile software development. So, that is the reason the last point states the agile management is all about being able to cope up with uncertainty. So, this is about the principle of uncertainty and agile management. Now, let us see the scientific proof of the existence of this agile management. The existing organization must determine a baseline for the experiment. The current inventory level must be established along with the production rate. It may be necessary to correlate the existing results and to map use cases to stories. What is that story? Those stories you call it as user story. When the story is pretty big, you call it as an epic. When you break down the epic, you break it down into smaller stories. Such stories is called as user stories. If you have not seen that, you will be seeing it in the future sessions. Two stories or function points or features. When it is been called as user story, which means you are going to use a Scrum framework. When you are going to use a methodology called as feature driven development FDD, you call those stories as features. Each and everything you call it as a feature. The chosen agile method should be introduced under controlled circumstances and the results should be measured. If the prediction is correct, a reduction in inventory and an increase in the production rate should be observed. Agile management must cope with uncertainty and deliver better business results. To do this, it must incorporate techniques from theory of constraints, just in time, total quality management, quality assurance, Six Sigma and lean production. Agility is delivered through a focus on quality assurance, reduction of inventory, identification and investment in bottlenecks in order to increase the production and reduction in variance, which improves estimation and quality assurance. So, this is what brought agile management into existence, and this is said to be a scientific proof for this agile management. Now, my dear students, let us summarize this session. So, we saw about different theories. As a first and foremost theory, we saw about the theory of constraint. The second theory was just in time inventory. The third theory was said to be total quality management, wherein the first theory, theory of constraint, was shortly called as TOC. Second theory was shortly called as just in time, was shortly called as JIT. The third theory, total quality management, was shortly called as TQM. The fourth theory, lean production, was shortly called as LP. Fifth theory was related to Six Sigma, and then we saw a comparative analysis or the areas where these theories were made into usage. Then we saw three different phases of the scientific development. Classification. What are the three different phases that we saw? We saw three different phases of the scientific development, and then we went on seeing the principles of uncertainty and agile management. Then we saw the scientific proof for this agile management. Thank you.